All right, let me introduce what we're working on today to the audience. Hello, audience. Hello, internet. Tim and I decided to do something a little bit different today instead of our normal content layer stream. Since we were kind of interested for a while in building around MCP for effect, we decided that today we would start building towards an effect native MCP server implementation. And originally the idea was to wrap the official MCP TypeScript SDK as a starting point into effect. But after a little bit of research, it seems like it would be difficult for us to be able to use effect schema as the serialization framework on top of the official MCP SDK, because the official MCP SDK, TypeScript SDK, is very heavily dependent on Zod as the serialization, deserialization framework. And so since eventually the goal was to have our own anyways, we decided to start trying to build it today. So that's what we're going to be working on. We don't really have a very clear direction on exactly where we're going to end up or how we're going to build it. So you're going to probably see a lot of Tim and I throwing ideas around, but that's generally what we want to work on today, is sort of trying to see how we can put this together and where we end up. So I think I'll be driving at least for a little while. We might actually flip back and forth, depending on who's working on what. But yeah, that's kind of what the goal is for today, is to start hacking together an MCP server for effect. Jim, I don't know if you want to set up a branch with your RPC opaque thingy, and then you and I can both work on it together once you've done it.
Yeah, we can do that. There was something else I was going to do, but I've forgotten.
I know one of the things was opaque RPCs. I don't know if you told me the other one.
The JSON RPC protocol branch.
Oh yeah, Sebastian actually had some good comments on that as well.
But I'm not sure if we can use that, just because of the whole notification thing.
Yeah, so pre-stream, Tim and I had been talking about the general MCP protocol itself and how we can implement it using some of the things we already have in effect. One of the ideas I'd had was maybe building on top of Effect's RPC framework, since Tim did an amazing job making that very pluggable and nice to use. But we're not entirely sure that would work because of the way that the client and server communicate with one another, especially related to the notifications that can be sent between client and server. So yeah, we're not entirely sure exactly how this is all going to work out, but we'll see where we end up. If I can show maybe a little bit of what I had started working on while you get your branch set up. So earlier today, I had been working on just speccing out the model context. So model context protocol does have a protocol specced out both in JSON schema and in TypeScript. Although I'm not sure the TypeScript types are entirely correct. But regardless, they do have things spelled out in either JSON schema or TypeScript. And so I took that and kind of put it together with effect schema. But the problem with the approach that I took, where I've separated requests and results, so we can actually maybe look at a concrete example of this. We've got one of the first messages that an MCP client and server send between one another is the initialization request and response, or request and result. And we can look at that here. Where is the specification? Architecture, base protocol overview, I think. So messages that are sent between client and server are encoded using JSON RPC, which is a spec that you can take a look at if you want. But basically it's request and response are defined like very specifically through the protocol. And the MCP framework can define both requests, responses, and notifications that can be sent between the client and the server. JSON RPC also allows batching. So that's something we may support according to the MCP protocol. We have to support receiving batches according to the protocol, but we may support sending them. And then you can, again, if you wanted to look at like the TypeScript schema or the JSON schema for the full protocol, you can go to their website, look at the spec, and see it here. All right, you got to branch up. So anyways, one of the first messages that's sent between the client and the server as part of the lifecycle is initialization. So basically like negotiating the capabilities that the client and the server provide. And that's done in the initialization phase up here, where the client sends an initialize request, the server sends an initialized response, and then there's an optional initialized notification that the client sends back to the server. And that's spec'd out here. So this is the request itself. This is the result, and then this is the notification. The problem with this that Tim and I were discussing before the call or before our stream is that it separates not only like the association between the request and the response, so like the data you get between the two, but also like which errors can occur and whatnot. So one of the first things we were trying to figure out is basically like what's the best way for us to encode all of this information. And the original idea was to use schema.tagged request, which allows you to specify like the payload that gets sent, the success and the error types for a particular request. But a tagged request embeds the tag in the payload, which obviously results in like an invalid JSON RPC requests for the MCP protocol, because you'd have a tag sitting here in the params. So instead, we're going to see if we can use RPC to define like all of these requests and notifications. Yeah, let me pull up your branch. Copy link. Cool. I assume this just adds like the new.
Yeah.
Cool. Okay. Let me pull this down. Actually, I need to fetch, not pull.
Pull does a fetch.
It does? Okay. Well, goes to show how much I know about Git commands. Git check out. Let me see if I can just rebase my branch on top of your branch. Git rebase.
Origin school RPC opaque. That one did.
Cool. So let's do something. So I created, I'm doing this in the AI package right now. Maybe we'll separate this into an MCP package later, but I don't want to set up all the scaffolding for that right now.
Yeah.
So yes. And maybe we'll do this. Then maybe we'll just open this up to the side. I depend on RPC? No, I do not. Okay. Okay, I haven't done this with the new setup that Sebastian put together, so I need to...
You just need to edit to peer development, and then if you go to tsconfig,
Oh, I wanted to remove these. Oh, I forgot to do that. Yes, config the build.
it will be source and source. Is that reference source? No.
It does. Oops.
Yeah, you
Oh, I
just do
see.
build and source.
Okay.
And then you'll need to do a pnpm install.
And those are the only places I need to do it.
Yeah. And then you need to do a pnpm install to set up the symlinks. Great.
Great. I didn't save this, right? Yeah. Okay.
Then you'll
Cool.
need to import the actual submodule.
Need to delete it. Okay, so let's maybe grab the. Let's go to the initialize requests. And see how we can do this. So
If we use the method as the tag, and payload would be the params.
yeah, I want to see if you have a more elegant solution to this. But as I said before, this request meta is technically supposed to be in every single request. I'm pretty sure.
Uh-huh.
We can actually take a look at the protocol to double check again, but overview TypeScript schema. Yeah, so it's in the TypeScript schema. If we go to, and when I tested, so in every request, you can have these like this meta field, which can maybe contain a progress token, which is just something to associate progress. We can deal with that in a moment, I guess, but let's do this. Is this a struct or it takes anything?
It can be a struct or a schema.
Great.
So you can also just do a straight object.
Oh, nice. Yes.
Copy paste.
Best. And then we need this. But I'm going to steal my headers because they were useful for organization. Okay.
Do you want
So,
the copy the request mirror over to? Or?
yes.
Request token.
Just give you a string or a number. So, do you think just like spreading this into every request is the best way to go about this, or?
Yeah, it's fun.
Okay. Initialize request. So do you think that so the JSON RPC stuff has like the additional like fields that it needs for the spec itself, right? The request ID and the tag and the like thing here. So do you think that we'll handle these on the serialization level?
Yeah, it's more of a protocol concern than the actual schema.
Okay. So then it is really weird. Like, do I still encode this as a separate? It has to be encoded as a separate message, right? Like the result of initialization, because I guess it's a response.
The result. Initialization result.
I'm bringing over wholesale for now, but
As a result, a JSON RPC thing.
all of these are, yeah.
Yeah, so you just want the inner stuff. That would be the success of the RPC. Well, I guess you can make it opaque if you want.
Should it be?
It would be in the success field of the initialize.
Would it be a separate message as well, though? Because it's going to be sent. No, I guess you're right. We could just.
I mean, you can keep it as a class if you want, but you would get rid of the result field.
Okay. And then this would be success. Initialize result.
I guess instead of calling it request, initialize request, it would just be initialize or something. Yeah.
Okay. You could separate this out into initialize request if we wanted to.
I think that's fine.
And then
sometimes opaque types are annoying because you can't see what you can provide easily.
In this case, I feel like it's fine because the user is not necessarily going to be dealing with these schemas directly, unless they want to like override handlers or add additional handlers. But and then I want to grab your error schemas.
They might not be.
I'll double check, but
they might not be all inclusive.
I know. I just want to I wanted to grab them and then I can
Mm-hmm.
then we can check the spec. Okay. So the errors are in here. JSON RPC error.
There will have to be some kind of like translation because that's a tagged error there.
Right.
But JSON RPC doesn't have tags or anything. They just have like an error property.
I'm going to let's I'll rename this in a moment. Actually, wait, you know that you have a thing for code. No. Schema.number. Schema.very. Schema. Load. Okay, so we've got the base error type, and then we've got like the specific ones that it can handle. I'm just going to remove the MCP prefix. I feel like this is good enough for us to start with.
Yeah.
For a protocol. Probably a faster way to do this.
Search and replace.
I don't have a good search or replace plugin. And I could use the command line, but I'm too lazy.
That Vim has search and replace built in.
I know. I'm aware, Tim, but I've seen you use Spectre, so
I wouldn't use Spectre for that. But if you do a select a range and then type colon, Vim will target the range for you.
Yeah, I'll get better at it eventually. All right. So, if we take a look at, I think that like I'm not exactly sure what the best next place to go is, but I think that this is a good enough start to the protocol. I do want to bring over the comment from here.
Maybe add in a notification as well. This notification is sent from a client to the server.
I need the notification meta.
Notification requests don't have a response there.
I got it. What am I doing? This notification doesn't have any payload aside from possibly some metadata.
Okay. Would the success be never for those? Not sure if we can do that. I'm not sure if RPC allows a schema of never.
What does it default to? Void?
Defaults to void. But for memory, MCP notifications don't have responses. Even though they are requests, which is funny.
Well, we can leave it like this and see how far we get. So, all right. So this is like enough of a protocol to get us started. At least it covers the initialization phase of an MCP, like client server thingy.
Yeah.
In MCP, for the viewers who are not familiar with MCP, so this is the lifecycle phase we're referring to, this initialization part, where like capabilities and protocol version are negotiated between the client and the server. And then once this is established, I mean, before this can even happen, there technically has to be a transport set up for the MCP server. So MCP servers support standard input output as one protocol or as a transport. And they also support streamable HTTP. Previously, it was server sent events, which are still technically supposed to be backward supported through, I think, an endpoint. You get request to an SSE endpoint, I think, is supposed to be supported. But I think we should start with this and not concern ourselves with the streamable HTTP stuff quite yet. So for the standard IO transport, since the client launches the MCP server as a sub-process, I'm fairly certain this is a one-to-one relationship, always. And basically, server reads from standard in, sends messages to standard out, and the client does, is listening to the server. Batching is supported through standard IO. So you can get a batch of JSON RPC requests. Messages are delimited by new lines. Must not contain new lines. You can write to standard error for logging. You can't write anything else to standard out. Yeah. So if you actually look at the TypeScript SDK and how they do this, so I'll bring this over and I'll bring server standard IO. I'll bring this over. It's actually pretty simple. I'll get rid of the schema. This is the server transport for standard input output. Basically, it just binds a readable and a writable. Sets up a read buffer, which is basically just there to ensure that if you get sent a partial message, that it's not processed until you get the full message. So for framing purposes. And basically when the server started, it sets up listeners and processes the read buffer. So every time data comes in from the standard in stream from the readable, you append to the read buffer and then process it. And processing the read buffer basically only emits a message if it has a full message. And the read buffer is very simple. You're basically just appending to a buffer until you hit a new line. And then when you hit a new line, you deserialize the message and return it. I think that we can obviously do this with affect streams, maybe, but we can talk through how this will all look. So we can set up a.
You could probably reuse the RPC serialization for a new line delimited JSON.
Do MCP standard IO server transport. I don't know what to call this. Let's just do MCP transport. RPC serialization.
Was the HTTP stuff the exact same? Or how does the so obviously HTTP isn't bidirectional. What do the requests do? Do they just send you messages instead of they just use posts?
They just use posts except for SS for server sent events. So if you look at server streamable HTTP here. So post to MCP is like, this is like what you're supposed to do to handle requests. But I think there's this handling GET requests for server sent event streams that are also valid.
Mm-hmm.
But anyway. What were you saying about the new line delimited JSON? This one?
Yeah, it just already does the new line separation.
I can just copy this and change the content type. Do I have to change the content type?
Well, I think for the transport, you probably don't want to concern yourself about the serialization stuff, but you just want to kind of like work with requests and responses, and then later plug in how it actually gets written to the socket.
All right, so how are we going to start with this then?
There'll probably be something similar to the RPC protocol interface, where you have you're only dealing with the decoded types or partially decoded types.
Starting with protocol instead of serialization.
Yeah.
Okay, so let's take a look at the RPC protocol again. RPC server protocol. Okay, so I assume we're going to need our own because this I don't think works for our purposes, or does it?
Maybe copy part of it. You'll need. You could probably copy up to end, so from like run to end. The other stuff, you won't need, I don't think. Yes, the responsibility of this would be like translating from HTTP or standard IO or whatever we want into something that we can use for the logic.
Actually, maybe we can put this in the MCP protocol file. Since this is not really a transport, it's actually the protocol. I'm not going to worry about tags quite yet, since okay. And run is the method that gets called on a request from a client. Right. So that's why we have
that will
this
be a
from
message coming again. So I'm not sure what client ID it might be. Like, does MCP, because with Streamable HTTP, clients would have some kind of ID.
Yeah.
Because
standard
each request.
For standard IO, I think that we would have just a client ID of static 0, kind of like what you do with RPC test.
Right.
For streamable HTTP, there would be a client ID.
Does the in Streamable HTTP, does the server send back like a token, or how does it work?
I mean, there's a session ID.
Session ID. Yeah.
So let's
initialize result.
Start with, let's take a look at
So
this.
if we just rename client ID to session ID, I guess.
So in the Streamable HTTP transport, the server operates an independent process that can handle multiple client connections. This transport uses HTTP post and GET requests. The server can optionally make use of server-send events to stream multiple server messages. This permits basic MCP servers as well as more feature-rich servers supporting streaming and server-to-client notifications and requests. The server must provide a single HTTP endpoint path, which is the /mcp. For example, this could be a URL like /mcp. Servers must validate the origin, blah, 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 blah. Sending messages to the server. Must be an HTTP post request to the MCP endpoint. The client must include an accept header. Okay. Body must do one of the following. Sorry if you hear my daughter in the background. Okay, this is all about SSE stuff. Multiple connections. The client may remain connected to multiple SSE streams simultaneously, making the stream resumable. Servers may attach an ID field. No, this is SSE stuff. An MCP session consists of logically related interactions between a client and a server, beginning with the initialization phase. So yeah, I think you're right. I think we can make this session ID. Yeah. Because I think this session ID stays the same while the client is communicating with the server. Let's do. I think this would be a string. It doesn't have to be, but I guess. Let me just see. Yeah. Generates a session ID for the transport. Session ID should be globally unique and cryptographically secure. A securely generated UUID, JWT, or cryptographic hash. So it's got to be a string. Okay. And I guess the data that comes in would be, so close this. In my initial attempt at creating a protocol, I put together all of like the things that could come in So a client, these are all the client requests that could be sent. So I guess the data here would be the parameters of these request types, like the payload. And are you talking, Tim, or are you muted?
I was muted. If you do an RPC group of all the requests that could come from a client.
All right, so export class client request extends, or maybe request case. Okay.
Dot. You do RPCs and then pass in the group. You could probably make a typo last for this.
From client, do the same thing.
And then if you wrap that in the RPC dot RPC group.
I have to do typo. Yeah, there we go.
So there's the RPCs themselves. Oh yeah, if you do payload schema, then on top of that, extract the encoded type. What do you get? This.
Okay.
I'm guessing that will include notifications as well.
I think so. Because I mean, maybe we have a
It's
separate
going to be
notify
annoying
method.
actually because there's no discriminator on that type. So I will need to probably extract the RPC tag and add that in. So if you do like a union extraction instead of doing payload schema encoded,
You're gonna have to help me out here. I'm not entirely sure what you're talking about.
and there you do like extends infer current or RPC. And then create like an object with a tag field, maybe. And that would be the RPC tag, RPC square brackets. You will need to ensure it extends rpc.ini first. tag. And then what fields does any have?
God, this type is so ugly. What fields does any have? Let's take a look.
Or in that second extends, you could just extract all the RPC types. So instead of rpc.ne, you do rpc.rpc and then extract the tag payload success error middleware.
Oh, I see what you're saying. Look here.
Oh yeah, you can lift it up.
I can lift it up on more. Right.
You don't need to infer. If you just copy paste from the RPC module, maybe like the success extractor, because that's pretty much, yeah, so you kind of want that extends RPC, but yeah. And then instead of the success stuff, we would do our custom object. Yeah. We want the tag field.
This work.
No, you don't want to do that. You just want a plain underscore tag.
Right. Tag.
That's the tag. Yeah. And then I guess we'd only need the payload. And that would be encoded payload. Payload encoded. Yeah. So now we have a discriminator and the payload.
Nice. The question of notifications remains.
Yeah.
I think client notifications would have to go in here, right?
Yes.
They're handled through the same pathway.
Yeah. Well, client notifications can be in the request RPCs because they are sent from the client. But the server notifications would be in a separate group. The notifications sent from the server would be in a separate group.
Why?
Something that's fun.
I'm getting a never.
If you get rid of the extraction, do you get all of the RPCs? Yeah. If you remove the payload field.
This shouldn't matter, right?
No, it shouldn't. Okay, you might need to do it in 2 steps then. If you go extends infer RPC and then just return it. Just need to make sure it's going for each member of the union properly. Yeah. Yeah, right. And then if I would just move the extends extractor into here now and see what happens. There we go.
Weird. Okay. Is this going to be enough information for us to know what to respond with?
Not sure.
This we'll figure it out when we get there. Oh no, what did I do? Oh god. Oh god. Okay. I assume we don't need transferables.
No.
From server. I guess we could quickly do the ping request so we have the from server encoded defined as well.
Okay.
Is this meant to be the response though?
It's for writing stuff back to a client.
It could be anything. It could be a response.
So in this case, it would be a response to one of the requests or a notification.
Clear. Okay. So let's do the ping schema then, just so we have something that can go back and forth. Initialization. I don't know why I went that high.
Does it respond with a pong?
I actually don't remember. I don't think it did, but let me double check. Overview. Schema, TypeScript schema. Ping requests. No, the server can send a ping and the client can send a ping. There is no response. Very useful ping.
Very useful. But there's no pong in here.
The ping issued by either the server or client to check the other party still alive. The receiver must promptly respond or else may be disconnected. Okay, but what do you respond with?
Yes. Is there a ping response or a pong?
Pong? Ping result? Nope. Okay, maybe we can search here. Ping. Actually, we can probably look at the implementation of source. I don't remember if it was in here. Ping. No. Source. Shared. Protocol. Automatic com.
It's just an empty object.
Okay. That's good.
An empty payload. Success of Schema.struct.
Okie dokie. This is the best protocol.
Simply the best.
So we want
they will be added to client requests as well.
RPC server request RPCs extends. Training request. I haven't checked if we've gotten messages or anything. I don't think we have.
No.
Okay, and then export type. You probably just. We could probably make this more generic. But it's just. Let's not try to be too fancy. No, for now, I think that's fine.
We also need the. Well, I think from server you don't need the tag. You don't need to discriminate in responses.
But the server can issue requests.
I guess the client will need it, but
I guess the protocol is going to be run.
We'll also need to add the responses into that union. The responses from the client. No, the responses from the client requests RPCs.
Here?
No, we just need to extract the types. So we're extracting the payloads, but we also need to extract the successes. Not in a separate union.
In a separate union, okay.
From server responses, I don't know.
It's just such a weird. What about to?
I think that should be from server encoded. And the other one below it should be like from server requests. Because the from server requests are kind of like the quite unique things.
So hang on. We can maybe do something like, so from client is requests, right?
So those are the messages coming from the client.
Yeah, so client request encoded.
And then we need a type for...
Yeah. Client request encoded. Server request.
Server responses. Oh yeah, server requests. Sure.
Okay,
so
server
that
response.
Would be a union of server request encoded and server response. In this end. Because the server can both send requests and responses to the original client request.
Right, and this would be server request RPCs, and we're getting...
No, that would be client.
Right, client request. Oh god, client request RPC is, and this is going to be the
success value of the response. Well, I guess that could be an error as well. That's kind of like a result type.
yeah.
So maybe just an exit or an either. No, you want the either inside. Or error. And that would be yeah. You might need a request ID, optional request ID in there. I'm guessing
also in the wrong position.
No, because either's flipped. Right on the left. Yeah.
You wanted me to put the session ID in here?
A request ID, an optional one.
Like an option or like this?
Yeah, string. And I'm not sure if we'll need that for client requests too. Because in JSON RPC, you can optionally send an ID on requests. You just need to associate the response with the request somehow. So if you have a batch of requests, you know how to map them back together.
Right. Do we need? Oh. Okay, so we don't have to handle the client response because that's on the client side. The server can request or respond. We receive requests from the client, and the client requests can have a client request ID.
Mm-hmm.
I think that they always have them in this version.
Okay.
Yeah, unlike base JSON RPC, the ID must not be null. So we always have an ID in this particular.
Okay. And it's a string or a number.
Oh my god, let me just do. Actually, this.
And then server requests. Do they have an ID as well?
Anything that's a JSON RPC has an ID in this particular spec.
So you just need to add it to the server request encoded. Disconnects.
I'm not sure we'll need it, but we can try to implement a layer for standard IO now and see what we're missing.
Yeah.
Well, I have to put. Oh crap! Where did you have that in the source? There we go. You'd probably be lazy. Does it matter?
Yeah.
Where does lazy R come from?
Function. Question mark. Double question mark process I'll send it in.
Well, I want to do it like actually,
You're inside a generator, so you don't need sync.
oh, you're right, Tim. Why do you have to be right? Can I I'll see. Can I? What's the
Yeah,
syntax for like?
it's dot question mark. Yeah, I think it's that. Oh, question mark dot.
Oh god. Yeah, there we go.
Yeah.
We got there. Okay. So we could probably read from the from the input stream using the node stream.
I'll just listen for the data event. I don't think you need back pressure. Keep it simple.
I think in their implementation, just double check here. Yeah. If we're going to be doing something similar, we might as well look. Nope, not this. Here. Yeah, they do like the read buffer thing, then they process the read buffer.
Yeah. So you just need the ND JSON parsing stuff.
Yeah.
You could either reuse RPC protocol or copy paste it. I think there's make constructors for the RPC serialization. Yeah, so you can just evaluate the effect and get back.
And then just call and save make.
Yeah.
What do we say? MDJSON?
Yeah.
Okay.
And
This
then you
does
can
the
just go
back.
parser.decode data. And then if you get any results from that, push them somewhere. So that'll be 0 or more items, depending if you've got a partial chunk or not.
I assume that we're only pushing it.
For every item, you need to call run.
Yeah, we don't have a run quite yet.
Yeah, so this process starts when run is called.
So we also need to consider like the cleanup of this, right? So how do we want to do this?
I mean, for now, you can just push them into a mailbox. RPC tries to use straight callbacks to like cut out indirection.
What does this give us back? A string?
But in this case, it will be the encoded types. So it will be the client requests encoded. And then you use unsafe offerall. And that will have to be cool.
And can I register? I guess I'll register a finalizer in here to clean up these callbacks. Same way that they do here. I mean, we're not going. We're technically not going according to spec here because, like, I mean, we're not going according to spec because I think transport has to have like a start and a close method. I can double check, but let's double check custom transports. Maybe not.
So you're planning to create the transport interface and then use the TypeScript SDK?
No, I was just looking at like the actual spec to make sure we weren't like going too far out of like.
All right. Yeah, I think the start thing is just the TypeScript SDK interfacing. Yeah, you just need to move the data handler to a function. Going to be on data. And then, no, you just move the listener. Because you just need a stable reference to the function.
Oh, right. Sorry. So the standard in would start listening on run, right? Or would it start if?
Well, here we're listening straight away, which is fine. It'll just buffer until run is called.
Right. See what they do. Okay, take it off. And then they do this stuff. That's fine. We can do this. We'll set up the error handlers in a minute. Leave this comment. Do you want to set up the error listener?
Yeah, we probably should. It's kind of like a defect when that happens.
Yeah, it would be a defect.
You need to make that, wrap that in effect.sync, that finalizer.
Or do. And first you tell me I don't need effect.sync, then you tell me I need effect.sync. Tim, make up your mind. All right.
I'm not sure where the errors would go.
Me either.
You can put them into the run. You just push them into the mailbox for now.
You want me to push them in as unknowns?
There's defects.
Defects.
So we mailbox are unsafe done.
Unsafe done. Exit. I. Error.
I would technically you should have the finalizer before you attach the listeners. Technically.
Set up the listeners. It's just pretty clear what this is there. Okay. So maybe we can set up.
That would be that gets past the function. You just do it inline.
Okay, fine. Let's return it back.
So you just in here, you just go mailbox take. Oh, you could do that.
Why not?
And then maybe just do a while loop.
Do you want me to use an effect.while, or do you want me to just use the regular CPU bound? Wow.
You use a regular one.
While.
And then you would pull, maybe just do, do a single take, or you could do take all.
Since we support batching, and we're still going to be processing requests one at a time.
Yeah.
We could just take all if we want to, because technically in here, like we can batch, so maybe we just do take all, and then process them all process each batch one at a time.
Yeah. So, or requests and then send it off. And then you would pass it to that function, the write request function that was passed in.
Yeah, sorry, I was just looking at something.
And then I guess it would be an empty request session ID, because the standard IO doesn't support session IDs. Is that right?
I think it does. Wait, no, it doesn't.
Okay.
Maybe it does. Yeah. Look, transports.
You can only have one client connected at a time.
Yeah, so it doesn't matter. It can just say 0. That was an effect? Yes.
Great.
Oops, why is this unhappy?
Because there are more methods than run.
Oh. Thought it was unhappy with run. Shall we do... Well, hang on. Something's unhappy here. Boolean? What? Oh, can this return a Boolean?
You want to extract the first argument only. It returns a tuple. There you go.
There.
And it's a chunk. Oh, yeah. Yeah, that's fine.
Okay, so should I how want to call this response, even though it's
Yeah. And then here we just do a simple standard out, right? Is it?
yeah. What do they do over here?
First we'll need to encode it with our parser. And then write the result.
Right. And then, so if they write it and it returns false, they're great.
Yeah, if write returns false, then I mean you don't have to wait for the back pressure, but it's probably good.
Or
Technically, this is not correct because we need to go to JSON RPC first.
yeah. Is our deserialization even correct right now? Because it's not.
No.
Well, no. No, it's not. Well, let's get this scaffolded out, and then we can deal with key.
Yeah.
Standard out dot once drain. What do I have to do? I have to do this in an effective AC. What does it want? One time listener.
Yeah, you'll need a async.
Yeah. Yield. Wait a minute. Not gonna work.
No. You'll need resume effect of void and a callback.
That feels. Okay. So we have run, we have send. What else do we need? We need end. I don't really know.
I'm not sure if it will do anything. End in RPC is when RPC server like protocol socket server. Yeah, it's just ignored for sockets.
Okay. And then for the disconnects, I guess we just make a mock mailbox. because there would only ever be one client connected at a time.
Yes. Yep.
All right.
I think you could probably get rid of end for now. RPC only uses it for HTTP. And what does client.end do? Oh, yeah. End is when the server has finished.
Well, if we're using streamable HTTP,
Yeah,
maybe we'll want to use. I say we keep it, and if it ends up that it's just a void in that too, then we can just remove it. But
okay.
The last thing we need to clean up here. Let me just make a quick layer for this. Workhouse layer, protocol, standard IO. Actually, just scope. Scoped. Still need to fix serialization.
Yeah. I'm just thinking it might be possible to use RPC for all this.
How? Would it be like how I said before, where you'd have an RPC server on the client and the server?
Yeah, you would wrap a client and a server on both ends, and then route things into the right place somehow.
Well, let's get the serialization figured out for this, and then maybe we can do that as like a next step, either off stream or next time or whatever.
Yeah.
All right. So the first place we need to fix serialization is on data, because parsing this not going to give us this. It's just going to give us a string.
No, it's going to give you a JSON RPC shape.
It's going to give me a JSON RPC shape,
which will either be, what would it be? Yeah, it'll be a JSON RPC request or a notification.
Well, the notifications also have the same shape as a
yes, so it'll all look like that. Yeah.
The only thing that's different is the response.
Type there and put it in to there. Yeah.
Yeah.
And now we just need to translate it into you do a results.map into bow shape.
So we're going to need the method and the params.
And params. The method will be the tag. The payload will be the params. That's he'll complain because we're going from like string to whatever. So that's fine. And then for the right side, we need to go from yeah, so that's fine now. We don't need to worry about that. We need to worry about send. So in the encode, instead of response, you'll need to put a JSON RPC response or result. I'm not sure what results look like. Yeah, they go.
They differ if there's like an error or a result.
But in here we do need to handle notifications differently. So maybe we could just check if the tag starts with notifications or something. I don't know.
Yeah, we could do that.
So notifications need to look like a request, but responses need to be responses.
Yeah, so this is the response shape. So
what do notifications look like in the spec?
Just like a request, as you said.
They don't have an ID though.
Correct.
So we can just see if the ID is there, and if there's no ID, send it as a request.
I think we made ID required here, which we shouldn't then.
So for notifications, it wouldn't have an ID.
It's valid. That's correct.
Yeah, it should work. I mean, it's only for internal use, so I'm not sure if it's worth it. But
it'll help us in case the spec ever changes.
Mm-hmm.
What did I just do up here? Did I do this wrong? Oh no, I have to narrow based on. I'm still getting request ID as like a thing here.
Probably just defaulting to that branch when it's any or something. Oh, you're just going to check for the presence of an ID, right?
I was going to, but
Don't really need his property there. His property does an object check as well. It's more like going from a none. That would be method would be isn't payload there?
I think I need to remove whatever I did up here. Yes.
Okay. Yeah, just make it an optional property.
Wait. Server request is not the right place for this.
Server requests. Yeah, that's right.
No, because the notification we have in the client request RPCs.
Yeah, but usually notifications come from the server, not the client.
Correct,
That one
but
is
we
an
have
exception.
a separate type for the so request. So hang on. This is the thing where this should be optional, right?
Yeah.
Not here.
Yeah, sure. Yeah. Initialize does not have a...
Because it's because
responses are different.
yeah. So we need to, if we have a request ID.
So that makes it easier. If payload is in response, then it is request.
Yeah, then we can just do this. We can do.
No, we're in the request branch, so what we had is fine. That's what's up here. Yeah. And then in the other branch, we would do the even.match. So that would be an error response.
So let's just do it this way. Oh no, we can't. Gotta do it here. Okay.
Unless you did a spread, but it's fine.
We'll just be verbose for now, especially if we're going to change this to use RPC at some point. Let's do this. Take this. One left. This is response.request ID.
Yeah.
This is.
So you extract the error. What is that type even? Oh, we haven't added any errors to any of our RPCs yet.
All right, so we'll just.
In this one, we just need result.
Oh.
In the unwrite, you can just extract result.
Response.request ID.
This.
Left never void is not assignable to left never empty object.
Let's be,
Okay.
because it's a union.
Okay. messy, but I think it's good enough.
Cool.
It would be interesting to take this and try to embed RPC servers on both ends.
Yeah. I think we'd have to do this anyway somewhere so we can route it to the right place. Because if there's a payload in the response, or if it's a notification, then it would go to the client, embedded client. But if it's a response to a request, then it will go to the embedded server, and then vice versa on the client side.
I think it might end up being a little bit cleaner, though. To have like the server embedded on both sides, and like you said, handle the routing separately.
Yeah.
Not sure. Well, I'll commit this to this branch. I think you can get rid of this. Actually, I'm going to keep this around. Yes, really. Yeah. Um. I think I have a whip commit in here I want to delete.
I guess I'll just merge that opaque type in.
Yeah. Cool. Well, I think like off stream, we could probably keep iterating on this. Maybe like put an RPC server on both ends, like you said, and see how that feels. Because it would be kind of nice to like leverage RPC as much as we can, since there's so much nice pluggable functionality, and then just have like a routing layer that sits on top. Maybe. I don't know if that's going to just be more complex.
Well, yeah, some of the complexity that RPC swallows would resurface here, like interruption and all that kind of stuff.
Yeah. All right. Well, we'll think about it. Cool. Well, thank you everybody for tuning in. Hope you enjoyed our stream, and yeah, we'll see you folks next time. Cheers, everyone.